Hello students and welcome to Intensive Programming Lab. This is going to be our first lab. My name is Farhan Khan and let's see what we can learn in this lab. So our first lab is about arrays. An array is basically a collection of items stored at contiguous memory locations. They are used to store multiple items of same data type. They are indexed and a common style in C and C++ indexing, it starts from 0. An example array is given in the picture. So we can store different items at different memory locations which are contiguous. For example, as you can see, there are English letters, alphabets in bold case, U, D, F, D, A, E, C, stored at indices 0, 1, 2, 3, 4, 5, and 6, while the memory locations are 200, 201, 202, and so on. So let's first see how arrays are different than single variables and why do we need them instead of using single variables to store items. So here is an example with a single variable. So we declared a single variable of type short and we put a value. The variable is called age. We put a value equal to 23 and then we can print this value with the text. The age is such that so this would be printing out the age is equal to 23 on the computer screen. However, an array can store multiple values of the same type. So for example, we declare a variable age, but now the age is an array. So we declare how many items can we store or how many items are we going to store in this array. So in the declaration, you put the number of items that we are going to store inside brackets. So for example, you can see at line 5, short, that is the array type, the data type that would be storing in the array. Age is the array name, and we can store 4 items in this array. Then one by one we can store different items in this array. For example, at index 0 we are storing 23, at index 2 we are storing 65, and so on. So here we declared an array of size 4 and we store different items one at a time at different locations or at different indices of this array. It's important to note that a short data type takes 2 bytes of memory, hence an index is addressing 2 consecutive bytes. For example, in the given picture, byte number 928 and 929 in the memory locations stores the number 65 in as 2 bytes and at index equal to 2. Okay, so far we learned how to declare an array and how to store different items or values into the array. Now let's try to add this snippet to our previous program to see how we can print the arrays. So we have an array variable age. If we try to print it like a single variable, for example in this code cout, and we want to try to print each item of the array on a different line, this would print nonsense since we are not specifically asking for the indices of values to print. So in X, like inserting values in the array, when we want to access the array or we want to print the contents of the array, we need to specifically point towards the indices. So for example, in the next 4 lines, we are printing the value in the array at index 0, at index 1, at index 2, and index 3 respectively, which would print the values at indices 0 to 3 at a separate line. Similarly, we can copy arrays or the contents of an array to another array. Suppose that after filling our 4 elements array with values, we need to copy that array into another array of 4 shorts. So let's try this. We declare another array of the name same underscore age, and we assign the array, the elements of, try to assign the elements of array age into that new array. And let's try to print this out. This code would also not work because the array assignment similar to printing does not work like that. We need, when we want to assign the values of one array to another array, we need to point towards the right indices. That is, we cannot copy if we treat the arrays as single variables. So let's try copying the contents of the array one by one by using indexing. So we can copy the content of the array at index 0 into another array at the same index 0. In the next line, we can copy the element at index 1 of array age to the index 1 of the array same underscore age, and so on. And then we can print both arrays. So far, as compared to single variables, using array looks like a difficult task. So why to use them then? So the obvious advantage is naming. Multiple items can be stored and accessed by a single name and its corresponding index. For instance, instead of declaring single variable int age1, int age2, and so on, we can use int agn and store and access n different items by indexing age with index I equal to 45, for example, and that will store 45 at index I of array age. And you can see that we can also use counter and loops for indexing for easier allocation and access, and to easily copy elements. Here you can go through this example code for a while to understand how you can use a counter and a loop for the array assignments and copying. Arrays can also be two-dimensional and twice the fun. Can store more values in the form of a matrix or a table along two different dimensions. For example, here you can see we are declaring an array of integer type stud having 4 size along dimension 1 and size 2 along dimension 2. So it can have, or it can store 8 different items. You can see that we have 2 columns and 4 rows, and along each column and row we have a value. So let's get on with our first lab. In this lab we declare, store, and access 1D and 2D arrays. So you can follow the lab procedures from your lab manual. A guidance would be provided, so you can conduct the lab, and if there are any questions and issues, you can ask. Follow all the steps given in the lab manuals, all the examples given to you, and the tasks. At the end, your work would be assessed based on the completion and quality. Thank you for watching the lecture. Good luck and happy coding.